So I'm really, I've been looking forward to today's conversation because there are all these things here. And first of all, I'm sorry, I apologize. I got so carried away last week. I was going on, and you guys were so polite. Because wondering, wait a minute. It's normally it ends officially at 7:15, right? Not a half hour past, but a quarter past the hour. Okay, fine. So please don't hesitate to nudge me if you look at the clock and I forget the time. Let's see here. So today what I want to talk about is, did you all, especially Tanya and Cameron, I don't know if you checked your email just now, but in email I just sent you the slides I want to work from today. So at least you have something in front of you in case we're not able to project everything. Okay? Okay. So, so today I want to talk about, continue from last time, talking about the examples in this weirdest people in the world paper, this one here, okay? And start with that. And I was just picking out some examples myself, but I figured, we can just go around the table too. You guys can also pick out favorite examples to look at, to talk about. The main thing is that in each example, they're not just, showing the results, they're also giving a few hints about maybe why things are that way. There's a lot of, there's a lot of references. So you can always look up the references in detail yourselves and think it's worth doing depending on your area of interest. Whether it's, moral reasoning or cognitive issues like visual perception or social reasoning, they're all really different categories. So they have different ways of establishing these differences. So I should look probably to keep things honest, have to look at their methods, right? On the purpose of them.
Sorry,
but
where can I find a slide?
It's an email to, I sent the email just about 15 minutes ago, but it's okay.
I don't have it either.
Okay, it's going through Google Groups. It might take a while, but it's okay. You don't need the notes today during the session. You can.
Okay.
So that's the first half. Okay, I want to go through these examples, and also maybe talk a little bit about why like that. So that could be interesting. They have some conjectures, and these are all based on correlations, right? I mean, to really establish causation is a really big job. Okay. So this, and then after the break, I like to move on to this really punchy little piece by David Morris on magical thinking and relevant to all the AI stuff. I thought it's fun. So he's a curmudgeon. He's a good curmudgeon. And then this other one against procedurality, ostensibly about games, but how games are theorized. But I think its comments are actually very trenchant, and they apply to a lot of technologies. And this is what will segue us into Wittgenstein for next time. So that's what I thought today. Okay, just first of all, are there any questions? Just like in terms of the course or anything you want to bring up from last time? Where we were at. So, well, what do we? I can actually share screen. I might as well. And let's see. Hang on. Play in window. Yeah, this works. Okay. 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 All right. So, but I just wanted to walk through a couple of examples. Maybe you guys can jump right in, and pick out some examples from this paper that you think are particularly interesting that we can talk about. So, anyone have a favorite? Yeah.
So I have a broad observation, but I'll start with a more specific one. There was one point that really stuck out to me that I thought fascinating because I never would have thought of it otherwise. Is in the, I think it's 5.1, individualism and related psychological phenomena, but talking about individualism in relation to having a baby boom.
Oh, yes,
that
yeah.
American parents were the only ones in a survey of 100 societies, and this was, I think, all Western societies, but we're the only Western society that has a baby room. And I thought it was fascinating.
I was really stunned.
Yeah, and everything about the individualism was interesting. That more Americans prefer a choice of ice cream flavors versus 10 ice cream flavors. We like choices, we like to be, and I am definitely like that. But then as a broader observation, I thought there were a few comments on self-esteem of Americans and that were very like optimistic and self-confident. And I thought that was interesting because I don't feel like I'm like that. Maybe it's just who I surround myself by, but I feel like so many Americans put that facade up that I wouldn't expect so many people to actually do, just based on like personal conversations and experience. So.
I thought about that too. I mean, first of all, I was really struck. I mean, I didn't catch that the first time around when I read this paper. I only caught it this past week. It's like, wow, my God, 1 out of 100 is a pretty big deal. But the thing about the second point you made, I'm wondering a lot about method. That's why in some of those papers I'd be interested, I mean, when we have time, to actually look, well, how do they establish these things? So this paper is very important for this critical comment about the specialness of the test subjects, but there's a whole other set of issues having to do with how do you ask questions, how do you ascertain people's opinions or people's, and like you said, what people say to the questionnaire, maybe not how people feel. Even if they don't intend to, there's also that issue. But probably the general thing is still the case. Remember that funny paragraph where something like 94% American professors think that they're better than average. So that really got me. So okay, I better bring myself down a notch or two. So everybody, well, I remember as I was at Stanford, and there was a psych, my friend who was a psych PhD student in psychology studying infant language acquisition. Maybe I mentioned this last time. She would always debrief the parents. The parents would bring their babies in for like under age 1 to test them for experiments for how babies begin to learn to associate words, sounds with objects. Okay, and then she would always give them the T-shirt, and also say, clearly your baby is above average. So every baby was above average. So I think that's. Well, I was going to say it's human, but that's the point of this paper, right? Maybe the point is that it's more characteristic of certain societies that are based on individual dispositions than others.
I'm collecting data for a project. A student is looking at preschool test outcomes. And so we've got like 400 test scores and then a host of other variables to consider. But when we were working with the school to collect the test data, there were a lot of data issues, and some of it had to do with the fact that they had a range of scores, and the scores at the very top and the scores at the very bottom, they gave like meeting expectations, exceeding expectations, below expectations. And then there were scores at the bottom at the top that should have been like, outside of these categories, but they squished them all into those two categories. And when we asked them why they had done that, they said they didn't want to make anyone feel bad. That was one of the things they didn't want to do. But also they didn't want to, I can't quite remember, it wasn't completely coherent why they didn't want to tell the parents of the students who had far exceeded the standards that they were performing that far above. I found that really interesting.
But neither
And-
way, neither overly positive nor negative, or just not negative?
Correct. Both on both ends, they did not want to share that information with the families. They did not share it with the families.
Why do you think, anyone, why do you think that was, why did they do that, you think?
My speculation is that they, on both sides, they didn't know what to do with those kids or how to support them or how to help them, and they didn't necessarily want to address that with the parents. So there weren't resources to deal with the outcomes of those things. So they definitely didn't want parents, you know, having a negative connotation associated with their child, even though that child probably needed some intervention. But also on the high end too, they just didn't have the resources to do anything about it. Right.
Okay. Yeah. That sounds plausible. And I know when I was going through training for teaching in grad school, I remember being told these psych experiments where about the teacher effect, right? Teacher expectation effect, right? But this is more for I guess elementary school kids, where they were the teachers were told that kids in this room were above average and they were special, you know, and teachers, and then versus other kids in a different class who were below average and whatever. And they tested things like, how long did the teacher wait after asking a question before moving on? And teachers would be a lot more patient with the smart kids than with the dumb kids. The kids who were told were dumb.
Yeah.
Things like that. So
patient with the smart kids.
Sorry?
Patient with the smart kids.
Meaning they would expect something from the smart kids. With the dumb kids, they say, they're not going to get it. Let's just move on. In essence, yeah. Not giving them a chance to answer, as much of a chance to answer. Things like that. Yeah, and they also did follow-up tests they put them all together and they would test the reading. This is, I think, with the do like reading comprehension, things like that. And they would test before and after this kind of intervention after one semester, what would happen over a certain period of time, what would happen later. And indeed, their abilities diminished or put into the dumb category. In the smart category, the scores tended to be improved more, even though beforehand they were all drawn from the same pool, you know, of reading ability. So a really strong effect, you know, things after just one session, one period, I should say, one period, things like that. Okay, let's have some more examples. I mean, you can follow lines around this kind of, well, this has to do with the psychology part about, you know, disposition. We mentioned somewhere about disposition versus situation, where in American, okay, I'm going to count myself in the blue category, right? So in American cultures, apparently we tend to, I'll say we tend to explain behavior in terms of disposition of the individual. They use the word disposition versus explaining the person's activity or behavior in terms of their relation, you know, what their roles are in relation to their social milieu and what's expected of them, you know, and that comes out more, you know. That's I'll just see if I can find it here. The form helps.
There was parts on that in section 4.2. I mean, that was one of the most interesting things for me, was this idea of self-contained autonomy and a viewpoint of that versus understanding the viewpoint of roles and relationships, and that they're calling it holistic.
Yes.
Is this, yeah.
Yeah, let's go to that. So holistic, 4.2.
It is. That's where it first starts.
Look for holistic. I'll go find it. Holistic. Yeah, analytic versus holistic
And
reasoning.
4.3 is where they say analytic versus holistic.
Yeah, analytic versus holistic. Yeah, I thought, yeah, that was really interesting. So for holistic meaning what versus analytic meaning what?
So here he says holistic thought involves an orientation to the context or field as a whole, including attention to relationships between a focal object and the field, and a preference for explaining and predicting events on the basis of such relationships. Analytical thought involves a detachment of objects from contexts, a tendency to focus on the object's attributes, and preference for using categorical rules to explain and predict behavior.
Yeah, so this goes for everything, whether it's people or objects or words. I mean, that's kind of what I was ending on last time. Okay, if you want to just to rephrase. Okay, so for people, what would it be? It's like it's what I was saying about disposition, right? For people, in American standard American blah 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 weird culture, it was explain a person's behavior in terms of what we can read off that person, right? So and then in terms of objects, what about objects? So what would be a relational interpretation of the what a cup is, this cup here that I'm holding in my hand, versus a relational approach to defining a cup. This is famous. This what I just did here. This is actually examples that Heidegger used when he's talking about in a very famous essay, I think called "What is Technology?" I don't know if those of you who were in Adam's class may have done this kind of thing. Okay, maybe that very same essay was talking about what is a vase, or what is a cup, and so we can try this exercise right now with this cup here. Let's do the analytic approach to defining a cup. So how would you go about defining it by itself? What is a cup?
Analytically?
Analytically.
It's hard to describe analytically.
In fact, we're just to the end of the story, yes. Let's begin. Let's just try. Okay, try. We're doing object-oriented programming and we want to define class cup, right? So here's the class cup. So what are its properties and what are its methods?
Cup is a cylinder without a top.
Okay.
It has a handle.
Okay, does it have to have a handle? Not if you're Chinese. That's true.
Made of some non-porous material.
Right? It's made of some non-porous material. It has to, okay, and why does it have to be a cylinder without a top?
Well, for anything you can hold and drink is a cup.
So it holds drink implies liquid. Okay. Liquid. So you drink it. So liquid. So it's for liquids. Okay, interesting. But we can also have mention of a cup of sugar. Okay, so interesting. That has to do with volume then. Something about volume. Okay. And Heidegger has a fancy way of saying it. In a sense, this is also like Dao De Jing. A cup is not defined, he said, what is made of ceramic or steel or plastic. He didn't say plastic, I guess. But it's defined by what it is not, by the emptiness inside, right? That it has emptiness inside. Because if it were solid, we wouldn't use it as a cup. Which is interesting because already we're no longer defining the cup by positively in terms of what it is, right? But of where it's not. Already, it's interesting. It's defined in a complementary sense, PLE. Then it goes on, right? It also doesn't depend on the stuff it's made of. We were saying ceramic, non-porous. We could try to, but still, if you say non-porous, it's still defining it in terms of the positive statement about the nature of its matter, right? Another is handle. So that's a topological statement, right? That's a statement about its geometry or its topology without reference to its physics, its physical material form. Physical material substance. Okay, so that's interesting. So now we slid from physics to geometry. This is a big step. So now we're going from kind of the world of accidents of matter and to the world of form, which is pure, right? Tanya said cylinder. Cylinder is an internal concept. Right? So it's already we're bringing together very different kinds of ontologies together. Okay. But if anybody, well, we'll keep going. Okay. Are there other ways to characterize the cup? I just said, Chinese, and I drink tea all the time. Da, 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 da. Other people drink coffee.
Would color or anything be analytical or?
Yes, and the question is, would it characterize the cup? This is a cup with Canadian colors on it. It doesn't characterize cup, right? So probably there are properties of the cup which are accidental in this sense. This particular cup has accidentally these colors, but it doesn't characterize the cup.
Would instead, let's say that was making a ceramic studio with a glaze on top of it.
Yep.
Would that be
correct? These would be analytical questions, and then there are answers to that, right? The answer would be, yes, let's think about it analytically, and whether it's glazed or not would be inadequate, right? Because we have a plastic cup, a paper cup. So this is always in the category analytic questions and answers about this. Okay.
Well, then there's the question of defining a cup as distinct from other things that hold a negative space. Right.
There we go. Yeah. So already, yeah. And that's this is where we should use the board. And then thank you.
There's a whiteboard behind you.
Yes, and I'm using it so I can focus.
Announcing itself.
Okay. I need to get fat marking pins. So this is famous. And can you see what I'm writing?
Yeah.
Okay. The letters A, B, right? So you can say also positive. That's where I was last week. You can say positively, what is an A? What makes an A an A? Because I could have, let's erase the B. Yeah, I could have written, wow, this is the right ones.
I feel like that paper towels.
The paper towels were better than this thing, all right. Okay. I could have written a different ways, right? So this is like a lowercase squiggly a. Let's try the colors. Okay. Oh, well, I could have done this. I could have written a in like this in green with the alpha sign. Okay. All these different ways of writing the letter A, just as all these different ways, different kinds of cups. So could, in fact, we have several. Okay, different kinds of, well, we'll generously call that a cup. Okay, and that's sort of a cup too. That's probably not a cup. It's a thermos, right? So when they it has a handle. Okay.
But it's detachable.
So you see already, can you just hold it for a second? Right? This is from low. But now it takes into which that one is okay. But this one, well, this is where this is. Okay, Wittgenstein will be talking about this in the philosophical investigations when he talks about families. Okay. But what Cameron is talking about is if we have different instances, this cup, family of cup, family of the letter A, how could we distinguish cups from plates or A's from B's? This is a question. Suggestions? It's not an easy question.
I drink from a cup.
The fact that while trying to be still analytic, so not necessarily the fact that the empty space has sides all around it. I mean that versus like a plate that's flat.
This is we'll just go right into it, okay? Because we can say the difference between all instances of cups and all instances of plates, and then can say, is there, if it were analytic, we would say, well, there must be some property, must be something, all right? For example, I don't know, I would say to be practical, plates are flat, right? plates are flat. And you can be mathematical about it. You can say, well, the curvature tensor on the plate is satisfies some uniform bound, so it doesn't get too curvy at any point. You can make a mathematical thing out of that, right? So it may be, if I say plates are flat, I can make it more rigorous. It works for plates, and then cups fail at that analytic statement, but it still doesn't qualify cups, because maybe a flower vase, right, has all this curviness to it, but we wouldn't use it as a cup. All right. The word use comes up. I think that's what I think Tanya was saying just now. Okay, I drink, right? I drink tea or drink something out of a cup. So I Xin Wei drink, or people drink something out of cups. Okay, so it doesn't matter what they drink, but something drinkable. All right, so that has to do with use. Yeah.
Is use analytic or is that holistic?
There we go. Now I'll begin to open out. There's a word for that when we talk about language, okay? Because I was using the letters ABC, but it could be words like CAT or TREE, cat, tree. Shu Chinese, Mao in Chinese, okay? So in whatever language it is, you can write it down. Then we can ask, how do we know what it means? How do we know what this word means? And people try, and this is what Wittgenstein will be talking about next week, is what are these theories of meaning? Let's just pause there because we're going to get into it later on, okay? But use opens up to what in linguistics is called pragma. Pragma, have people heard of this phrase? So this is a formal definition, like what shape it is. Yeah, basically things that are qualities that are not accidental, based on it's made of ceramic. Okay, so maybe geometric, for example, or if it were a word, like how is it spelled? C-A-T, not C-H-A-T, for example. Formal versus pragma, P-R-A-G-M-A, pragmatic, which is use, okay? How is it used? So these are very, very different ways of characterizing an entity. Okay, so that's where we pause. We'll come back to it. Okay, so you can see where I'm, coming down on this. Pragmatic. So holistic. Let's go there. Can we have a holistic definition, characterization of cup? We started it already. Okay, so can we have a holistic? And here, let's read what it says. Holistic thought involves orientation to the context or the field, let's say field of use, this case, as a whole, paying attention to relationships between the object in question and the field, and a preference for explaining and predicting events, like things that are happening, on the basis of such relationships. Keyword is relationships. So let's do this exercise with cup.
It's keeping your tea warm.
Yeah, good. And what else? This is just for me. But
generally, it contains a liquid.
Okay. Now, more relational than that? Can we have a more relational characterization of cups?
I mean, I think the cultural context is very important here because, I mean, you mentioned the distinction, which I don't know too well, but a Chinese teacup doesn't have a handle, whereas pretty much all cups that I can think of in the US use handles when they're serving coffee or tea. And we can think about what's defined as a cup in its usage in that specific culture or society. So if you think about like a flattening of a cup, it eventually becomes a small bowl or like a saucer. if you
Yep.
completely flatten it out.
Yep.
But it still serves the function of holding a liquid, or
Yep.
even if you increase the size, it then becomes something else, like a pitcher.
Yep.
And so in that case, it's more of like, how is it being used, and what's in what way is it like culturally accepted to be such, would help us to define a cup in that sense, and where this would be a very non-essentialist way of looking at it.
Absolutely. So, for example, if we go along those lines, we say a cup is the what do you call these things in general? Plates and cups and saucers, kitchen, no, dining object, whatever. Dishware. So dishware. Okay, let's call it that way. That is used to drink stuff out of, personally. Okay. Then it's very elastic. That characterization is very robust, because we could use a bowl, or we could use a thing with a handle, or we can use a small, Japanese ceramic, whatever. But if it's used in that way, that's a cup. It serves the role of a cup.
I'd say there's an ergonomic aspect to it too, and that might differ culturally, but like, what makes a cup not a bowl or a vase? How can you physically interact with it based on our anatomy?
Now there's delicate, right? It then makes it relative to the body, so it's a corporeal relation to yeah.
Well, that also, Cameron mentioned size, and I think I was thinking at some point, a big enough cup isn't a cup anymore. And then it might be a vase. Right?
But suppose it's really like a flagon like this, like those giant beer steins. But I'm drinking beer out of it, it might be a gallon, but I'm drinking, I'm using it as a stein, right?
Right.
So using, and it could be funny, it would even seem amusing, but
right.
This is where theater comes in, right? The power of this kind of theatrical, So,
well, this is potentially where essentialist definitions just become very dull.
Don't allow that. See, that's the thing. They don't allow that.
Right.
Okay. All right. So this is a very useful example to come up, because we're talking about analytic versus holistic reasoning. Also brought up this difference between formal and, let's say, material. It's better to say material qualities. And another key thing is about the question of relationality. Okay. Another example. There are plenty of examples.
I can't remember if we brought this up last time, but I don't think we spoke about the description, whereas it's the on 3.1 visual perception, page 4. Just like the arrow line, and then the whatever anti-arrow lines, A and B being the same length. I thought, they are quoting another paper that suggests that this has to do with the quote carpentered corners of modern environments.
Yeah, that was interesting.
Which I thought was really interesting, especially because, straight surfaces are rather rare in like non-human contexts. I guess you get like cleavages of rocks that would be very straight, but mostly the environments are like are curvaceous, and that affects our capacity, or it influences our perception of things. I thought was, or at least that was the suggestion, was really fast.
Yeah, I thought it was fascinating. And use this fancy word ontogeny. What do you think this meant by that? In this paragraph, explaining it, basically, it has to do with what is it? the visual system autogenetically adapts. I mean, it's too much jargon, but it encapsulates something very important. And that we grow up basically from babyhood up, you know, we do living in worlds with carpentered corners. I really thought that was interesting too. Yeah. And then they contrast that with many cultures, you know, where the traditional vernacular architecture doesn't have that. So whether it's log cabins or ice houses, meaning igloos, or you know, adobe houses, even in the Southwest here, et cetera, et cetera. So yeah, I forget that because the modern architecture is pretty recent actually. Not that old.
Yeah, unfortunately, all of the all of the built environment that is now behind you on the screen is rectangular.
You know,
Extremely so.
yeah, yeah. And this is also where the methodology is quite important, because all these papers, I mean, these fundamentals, the papers about fundamentals of human perception, right? I mean, we forget how peculiar the built environment is for all of us. I mean, all of us reading this kind of stuff, right? So it's really different. I mean, I think in last semester, we talked about another kind of infrastructural given is the fact that we have 24/7 electricity. Just plug something to the wall, you expect electricity to be there, you know, and to not have it is considered exceptional, you know, which is not the case for large parts of the world. Stuff like that. Okay. The visual perception has a general point I think they make, which is a lot of these fundamental, what they call cognitive and perceptual capacities, they're not universal. They're not as universal as behavioral scientists might think. That's a basic issue. And the other issue is this thing about some things are more fundamental than others, right? We think that, oh, there are fundamental capacities like visual perception. And then on top of that, we have other kinds of capacities we build on top of that, like geometry. On top of that, we have other things like architectural style. So they have this idea of layering, right? And that's why this whole paper is really important, because that idea of building up from fundamental to social, cultural is not a given. It's not a given. Super. Yeah, that's a super point. Some others. Oh, spatial cognition. Remember the one about the table? Did we talk about the table last time? Yeah, I do it. I did a little diagram for that, so let me share that.
The arrows.
Yeah. Here, this is the one. Share. I need a bigger. Here. Yeah. So that's what it is. You know, there are two tables, right? And then there's one chair in the middle between them. It's facing the upper table first. And then you have, sorry, on that table, you have two arrows, they're both black actually, right and left. And then they happen to be facing on the planet, north and south, north and south. And then they turn the subject around 180, facing another table, and go into the first one. And then it also has a pair of arrows to his right and to his left. But you notice because it's 180, those two arrows, the right arrow is now pointing to the north, whereas before it was a left-hand arrow pointing to the north. Okay. And they ask the person some question like, which is the same arrow? Which arrow? I didn't word it carefully. I just put it this way: which arrow is pointing in the same way as the red arrow?
Based on that wording, I would do geocentric.
Because of the pointing to the same direction.
I don't remember how it's worded.
Yeah, I don't think they said how it's worded actually. I looked at this. Depends on how it's worded.
Yeah.
You know. So, and however they do it, they detect these differences that are based on small, what they call small societies versus weird society. It's those differences that are quite interesting. And they distinguish different kinds of space that people think. Yeah, very true.
It says participants were asked which arrow on the second table was like the one they
Like.
saw before.
Like, okay.
Yeah, that's weird wording.
Like. Yeah. And that's super interesting. That kind of stuff, it teases out different, actually, it's more than two. There's like three different kinds of spatiality. One is egocentric relative to my body, another that's egocentric, and then another is geocentric relative to absolute north, so-called, and allocentric relative to the room, maybe. Super interesting. Yeah. There are commonalities. That's something they bring about. Okay.
It does seem that there's a lot of these have in the, if, and this is just maybe a sense I'm getting, I don't, of these differences being really, what's similar about them is this relation, like how you're centering self, where, you know, how you're viewing self versus not self, versus like, what is your relationship to the rest of the world that you're perceiving? And it feels like a theme throughout this.
Absolutely, that's the theme, right? In other words, do you think of yourself in, quote, your own terms, or do you think of yourself in how you are related to the world? So that's, again, the holistic versus the analytic approach to thinking about self, objects, others, whatever. Yeah.
Just interesting example, like grew up in China. If you're asking for direction in the northern part of China, people will usually tell you to turn to the north or to the south. If you're asking a question in the southern part of China, people usually will say turn left or turn back.
Wow, super
But they're
interesting.
speaking the same language. Though.
Interesting. Super interesting. Super interesting. Huh. And as a joke, when I was learning Italian, I was married to an Italian for many years. We were told as a joke that if you go to Italy and ask for directions, it's always keep going, just keep going. They say simply diritto. Always just keep going, until you sort of get worried and you ask again. And it'll say keep going, but that way, keep going this way, keep going, keep going, keep going. Simply diritto. That was a joke. Actually, it's interesting because it may be, I don't know, it's my folk theory. In Venice, has anyone been to Venice? Okay, so what's really cool about that city? Well, of course, it's built on water. But the other cool thing about Venice, which is really, I think, is really fun, is that in different places in the city, you see these signs for the train to get to the train station or to get to some other major landmark like the main plaza, Piazza San Marco, and the sign. Oftentimes the signs one to right or left, okay, but there are also many signs where it goes both ways. The arrow goes both ways. So it doesn't really matter which way you go, you're gonna get there anyway. Because it's all really intricate. The graph of this, the graph is so dense that basically it's completely connected. Any major landmark in every other region just takes you a little bit longer to get there. So maybe it's simply diritto is actually okay. Just keep going, you're gonna hit it. Sooner or later, you're gonna hit it. So that has to do also with this kind of way that people grow up in their environment. That's the ontogenetic part. Okay, so folk biological reasoning. I think that was really interesting too. Let's go back to here. Super interesting. And forget the words. I mean, I'm using words to remind myself, but they use this notion of folk biological reasoning. And they talk about something like kids in New York City who have never been out in the country, lived all their lives in an urban environment. They have a certain different relationship to animals. Thinking about animals as categories than kids who grew up in a rural setting dealing with animals all the time, right? So that was the example, right? They asked the child, I think it depends on age. Anyway, what's the typical bird? And went to a bird like the robin, which is a very characteristic thing. But then there's this other group, what is it here? Mayan. It's the Mayan villagers. They were testing these people, these kids, and they would say, give us a characteristic bird or typical, they say typical, the word typical, and they point to this wild turkey. Yeah, which doesn't look at all like most of the other birds in that region, but it's very important to them because culturally it's significant, symbolically it's significant. So typicality is good, they define as goodness of example, the best example of a bird for you. Okay. So what's going on here? What's the you know, when you say that to the kind of urban kid in your city to give me a typical bird, then what are the features? What are they looking at, you think? What are they thinking about?
For kids in here.
Yeah.
I mean, birds that you would see around your place of residence, so like pigeons.
And what characteristics are we looking at then?
Smaller, kind of frantic.
Yeah, shape, size, wings,
Yeah.
2 feet, yeah, beak, right, feathers and feet,
We're
right.
flying around like in the trees or flying around or on like
flying.
telephone wires
Okay.
or something like that.
Yeah. And you see all these things that we just said, they're not characterizing, we're not characterizing birds in terms of a symbolic function they play in my symbolic universe.
Right.
Yeah. Maybe, yeah.
They're also, I mean, children raised in the city have a different idea of what animals are altogether. All of them, right? They don't, the first time I realized some children didn't understand where milk came from,
Yes.
and that they had to actually, like, it was so odd to me because my people are farmers. And so it's this relationship where animals and the animals around you, if you're in a rural environment, even now in rural America, the animals that are around you have a sharp impact on your life on a regular basis.
Yeah, absolutely. And this brings up this other point they made between rural kids or kids, not just rural America, but children who grow up in an environment where they deal with animals, whether quote wild or domestic. Even that's a strange division all their lives. And they say that around age, this is I didn't put on the page anyway. Under folk biological reasoning, they talk about how urban kids before age 7 they think about biological phenomena by analogy and extension from humans because they're in an environment where they have grown-ups, their parents, and themselves, and that's about it. Not enough to have a pet. But then between 7 and 10, they shift to about thinking about humans as part of the animal universe.
Page 7.
Page 7, thank you. So page 7. It's a big shift at that point. But this shift is different than the kind of situating of humans among animals that you find in other societies, which is much more integrated with animal life. Okay, super interesting. So compared with Native American communities in Wisconsin, there's Mayan communities in Mexico, the human category is much more integrated into the animals from the get-go. Okay, so yeah. And this thing about pets, right? We think of animals as what? They're pets, they're domesticated, meaning it's good for food or something. And this is called wild. Wild, that's it. Everything else is wild. So
I've heard before that that humans as animals, we are more compassionate towards or feel more connected towards other mammals. So when you think about like conservation efforts, they're more likely to use the polar bear or the wolf or the tiger than they are a lizard or a fish. But now it makes me wonder if that is universal or if that's American thinking, or what would someone in the Amazon think about that?
Right. Or this thing about species, quote, endangered species, and then we have this idea of conservation, which is just protect it no matter what. But then we get into these tangles when we're talking about indigenous rights, indigenous lands where they're actually living in the land, right? So they have to fish. And now, of course, we know that there's a more, mature notion of what's called stewardship. I don't talk about that, but anyway, stewardship that can be managed better by these peoples living there who have to live off the land for generations to come than maybe us who say, well, we just want to carve out a boundary and just protected as is, you know. So that's a different approach to, again, a very different approach to maybe to animal ethics. Okay. Okay. About ethics, I wanted to go to also this questions of moral reasoning, and this is more considerably more abstract. Moral reasoning is late in the paper. Moral reasoning.
Yeah, it's in 6, I think.
Oh, it's in 4.4.
Oh no, it's
The types of moral reasoning that
yeah. They talked about the ethics of autonomy,
yeah.
ethics of community, and ethics of
73, page 73, 4.4. Yeah, I thought that was really interesting because it's considerably more, you know, rich. And that has to do with because it says something. I just want to see what you think about this because this is a very big claim. All right, they say that in the West we think in terms of we talk about morality of some action. We think in terms of justice or harm versus care. You know, but they say there are other bases for moral reasoning that we have in let's say in other cultures having to do with two basic things. One is the fulfillment of interpersonal obligations, you know, the role of the individual in society. And we can see that in traditional Asian societies. And also this idea of holiness. I found that interesting. This idea of divinity and holiness. I was wondering if you can maybe unpack that a little bit. It's not the same thing as church going. It's a different sense. Can somebody try to unpack that? What might be meant?
What did you say?
Holiness and divinity, a sense of divinity, but not the same thing as what we think of as church, faith, church in the Western sense. Something else.
In a lot of the religion classes here, they talk about the difference between, you know, religion and faith. That's a very different difference.
Yeah. That's I think we need to unpack that because I'm sure this means something different.
Yeah.
in the last paragraph in the section 4.4 talks a little bit about that more, saying that people are perceived to be the bearers of something holy or godlike, and that they have an obligation to act in ways that don't degrade that. It sounds to me when I was reading that like something along the lines of the sanctity of life.
Okay. The ethic of divinity requires that people, I'm reading here, treat their bodies as temples, not as playgrounds. And so personal choices that seem to harm nobody else, food, sex, hygiene, are sometimes moralized. Okay, very interesting. So it's not even a matter of what we call social, you know. And probably for me, having been born in the States and raised in the States, this is probably the most distant for me. It's because that's not how I hear people talk about morality, at least in this context, in the context I'm familiar with. So I think it's interesting. It's very interesting. So not the same thing as thinking of yourself as a god. It's different. It's thinking of yourself as having this kind of divinity. Not the same thing as thinking of myself as God at all. I think that's probably the most different way of thinking about it. You could see. Okay, just that. And there's something else too. I keep saying that this notion of the church is very peculiar to the Judeo-Christian tradition in Europe. It's not the same. You don't find the same kind of thinking, whether in Bantu or traditional Chinese thinking. It's not the same. Not the same. Different sense. Okay. So even the notion of religion itself has a very particular history in Western history, and doesn't work the same. So it doesn't read the same in other cultures. Okay. Let's see. Okay, so let's see what else.
It's, that's also, I'm sorry, I was
That's
just thinking that's also really profoundly different in this, in terms of how you view yourself and others. It's still, in this case, yourself is connected through to others through this, whatever's this holiness, right?
There is something in contemporary philosophy talking about what's it called, like hapticality. I'll write on the board. Hapticality, which maybe we'll read it sometime, which basically has to do with feeling the world, the way it's termed is feeling the world through others. So, now we're jumping a little bit ahead of the story in terms of intellectual history, but usually I draw this cartoon. I'll draw it now. Some more of this. I'll erase it. Ooh. Okay. Break. It doesn't work. I'm making it all worse. Green. Use this. Okay, can you guys see this green figure?
No.
Sort of.
It's not gonna work. Red. Let's try drawing. Not wow. There's Sharpies here. That's very dangerous. Oh my God! This is a box full of Sharpies. Oh God! This is terrible. Funny, it'd probably be easier to do this in here, green in Zoom. Wow. Okay, try this one. All right. Can you see I'm pointing to a figure?
Yeah.
Like a star-like human with a
Yeah. Okay. No. I know.
And a book.
And an object. Okay. That looks like a house. Okay.
house.
House. Yeah. Okay. I say it's a house. So this idea, this gets into again the question of representation. All right. So how do we get access to anything in the world? Well, see, hear, touch. Okay, senses. All right. But what if it's something like a cylinder, like we mentioned before, or cylinder, or even something like Julius Caesar, historical figure, or even better, unicorn, let's say, or triangle. Now it gets tricky. Okay, so let's try. Okay, just start with concrete things. If we want to get a grasp of a cup or of an animal, how do we go about it to perceive it, to understand what it is? This is a question of science.
Okay. With representation or
with some representation, and representation is generated how?
Well, we tend to abstract qualities that separate that instance from other types of instances.
Yeah.
So for mammal, we would abstract like the shape with like some central body figure with 4 limbs and a head.
I'm going to try to draw a lune, a crescent for the moon. Okay. Okay, just a crescent for the moon. Okay. So we could make a representation of the moon this way, or we could make a round circle represent the sun. I just drew a big circle with rays coming out of it. Since it's so faint, you probably can't see it.
But it's interesting because like these representations are embedded within a very rich context that we're like, if you, I'm sure if you went out and around the world and showed that spiky circle thing, you'd come up with a whole bunch of different things of what that is.
Sea urchins, right? It could be starfish, absolutely, absolutely. So already, that's a very great point because that means that there's no such thing as a sign, or this is called signifier. Signifier by itself instantly meaning something in the abstract. It's always interpreted. And this is what Cameron's pointing to, right? So that means that even this circle with spikes coming out of it is interpreted relative to an existing set of symbols, okay? We don't have time to read in this course anything by Charles Sanders Peirce, but he is probably the most profound writer thinking about questions of science and semiotics, okay? Science, how science works, okay? So if you anytime want to think about how science works, this is one go-to person for sure. And what makes his notion of science richer is this question of science themselves are already interpreted, okay, by other science, okay, or systems of science. But I'm jumping ahead. Basically, the starting point would be something simpler, is just a signifier and a referent. Okay, just the squiggle itself and what it's supposed to point to. So this is a more precise way of beginning to think about representations and how representations work. So I deliberately drew these two squiggles of the crescent moon and the sun as the prototype for ideograms. Okay, because in Chinese, right? So we have Chinese characters, yuan and ru. That's all the Chinese I know. Okay, we're going to ask experts here for that. But what's classical, right, is that these are particularly simple examples of particular kinds of ideograms that come from a pictorial representation of the object. But most things don't work like that, right? Because no, I shouldn't say this wrong. But there are other kinds of entities and concepts that don't have such an easy relationship to what you can see, touch, feel. Okay. And the example I'd like to use let's just keep it at that, okay, for now. So we already have these signifiers, these squiggles, what they're supposed to be referring to. And we have this human being here. This is interpreted. Some entity, some subject can need to interpret it for it to make sense. This is what Peirce brought into play. Because classically, or think in terms of computers, we just need to worry about a relationship between the signifier, the squiggle here, and the actual thing, like the actual moon up there, or this squiggle here, or this circle with spikes. These are two different kinds of signifiers, right? One is Chinese character, one is just a diagram. They both refer to that big ball of fire out there in the space, 93 million miles away, as if that's all we need to talk about. But as we pointed out just now, we're missing a really key ingredient, which is the interpreted. It's called the interpreted. So it's a triple: interpreted, signifier, and signified.
Well, then SUN is equivalent as well.
Say what?
SUN
SUN
is equivalent. Right. Like next to the circle with the spikes, so then SUN, they're all representations.
Yeah, absolutely.
Okay. It doesn't have to have some type of visual or like qualitative.
Exactly. So signify. So in fact, even a gesture, right? Even a gesture could be. See, this is the thing. It's really cool, right? With us, we're sign making people, creatures. Right? We can make signs in all sorts of modalities. So actually, it's interesting to ask. What about my voice? What about the verbal stuff I'm saying? And that is tricky, because those signifiers have to persist. What if they don't persist? Like my voice, is it a sign for something? I don't know. Wait a minute. Okay. Wittgenstein has this. Wittgenstein, I think, is really hilarious, right? I mean, he's got a deadpan humor, and really, I mean, I hope you enjoy him. I had to think of him as a joker too. He says at one point, consider a chair, and I use the word chair to refer to this thing I'm holding in my hand, okay? And then so I can say this chair. I'm going to sit in this chair. This is my chair, okay? Consider the word chair. And it's referring to this object here. Suppose this object were to disappear. Does this word chair still have the meaning? If its referent disappears. You know, questions like that. So they're thought exercises so that we can be a little bit more less hasty in thinking everything's very clear in terms of signifier, signified, as if that's enough. Any questions so far? I'm going too far here. Okay. But not everything's different. I mean, I want to point out on page 69 in that paper, there's a whole bunch of commonalities that they pointed to. Okay, there are interesting commonalities. For example, they mentioned the ability to perceive different colors. But it may be the exact boundaries between red and orange differ culture to culture, but that we can distinguish different colors, and roughly that's something we find, what people have found to be really common to a lot of different cultures in different categories. Another one is facial expression, right? To be able to detect when somebody's happy or show happiness or disgust or whatever. Okay, maybe what you call it might be different. Another is what they call analog number. I don't know what they mean by that. What do you think? Analog number sense. What do you think is meant by that?
Where is this again?
Page 69, at least that's
No,
what I
my
think.
pages don't match your page.
Oh, sorry. Okay, let me go back and look and see. The 9th page. Thanks. Thanks, Rachel. You can search for analog. Search for analog number. Oh, somebody make a guess. We can make up something. You can interpret it. It said it's sensitive to quantity, but limited in accuracy.
The definition from the Merriam-Webster dictionary, I feel like is not what they mean. But it says each number is represented by a suitable physical quantity whose value measured in some preassigned unit is equal to that number in question.
Oh, that's lovely. Interesting. Read it again. Sorry, say it again.
Each number is represented by a suitable physical quantity whose value measured in some preassigned unit is equal to the number in question. But that's the definition in relation to an analog computer or analog.
Ah, okay. Maybe just the word analog, just the analog part. Actually, this is very important because that's one of the things I wanted to talk about today. Is this thing about today. I want to at some point I wanted to get through this question, these different, just have working notions of analog versus digital, what data means, what algorithm procedure means, and that kind of stuff. But so analog, yeah, analog. We don't have to have strict definitions, but just have some distinction, analog versus what. So, well, let's go right now. I mean, maybe the word analog itself we can sort of pick up on. How would you like to distinguish analog from other stuff? Analog means what?
I mean, culturally, I always kind of thought of analog as the opposite to digital. So like by hand or by being mechanical, not electrical, or something like that. But
That's one. Yeah.
So, yeah, for me, analog, digital, it's going to take on one of two values, 0 or 1. And analog is can take on, and
Yeah.
other values.
Here we're talking about what is it? This is in the context of let's say societies that maybe don't have access to computers and computation and that kind of stuff very much. They don't need computers to get by. And yet they have a number sense, a numerical sense. So I think in that context of analog, there's not even the other in terms of digital. Digital doesn't even exist as a system, just a relevant category.
It's a way of simulating.
What do you mean by simulate?
So, of course, we are in a digital area, and we are talking about analog. It's about a way of representing the data to a precise calculus way, but it's simulate with the curve.
Well, that's kind of like this thing about we just talked about digital versus analog.
Yes.
Yes, but what I'm asking, can we characterize analog without referring to computers at all? Or, you know, sure, I don't mean at all, without referring only in distinction from computers, simulation, digital.
Well, I mean, I think the word analog, I mean, it's an analog of something. It's a representation. It means it's a symbol that has a relationship. So I have 3 apples, and you all know what that means because we have an analogy for this real thing, 3 apples, and that's the word 3.
Okay. Okay. All right. Let's work with this. Okay. So there's a way to think about analog in terms of material, matter. Well, apples. Okay, apples have real stuff. They're made of actual crispy, juicy, that's good stuff that we can bite into. Okay, and this is going to come up with the David Morris article that we'll talk about right after break. Okay, so in other words, you can eat an apple, right? And we can't eat the word APPLE and get sustenance from it the way we can get sustenance from an apple. So that's one thing. And Tanya talking about 3, the number 3. Okay. Even more than the fact is, even more than the question about digital is that there's this thing about notion of number versus the physical apple. You know, the apples. And so that's interesting. So maybe there's a distinction. Okay, the analog refers to the objects of my experience that I can actually, you know, live with. Okay, and that actually function as part of my sustenance in some way. So we can think about like analog, but also, you know, pick up the VR, right? We have analog versus what? So we have models of chairs and tables, you know, in a game engine, a physics engine, something, and then we have physical chairs and tables, physical tables, right? So yes, that's what we're talking about with simulation. I was talking about simulation, right? We also have the notion of the model of a chair, meaning the concept of chair. Or we have a geometric characterization, planes and cylinders. So we would think of that as outside the category analog. So I think that's okay. That begins to get into this question about distinction between formal and material. So maybe on one side, we can put characteristic notions like analog and material, matter, physical, and put them in a bag. Okay. On the other bag, we can put in notions like formal, simulation, computational, these adjectives here. Okay. They don't mean the same thing. Okay. But these are 2 different families. Okay. That's time. It feels like it's time for a break, but I just want to check this paper here. Yes, I think that's enough. So let's do this. We'll take a pause now. I think that's enough. We'll take a pause, and after our break, we'll go into David Morris's curmudgeonly thing. Okay, and then we'll also continue with the procedurality. Okay, let's take 10 minutes. I'll see you in 10 minutes.
Thank you.
Okay, talk about the Morris stuff. Preview. Okay, first, Cameron, I just saw this note. Is it in Padlet?
Which note?
You had a note I just saw an email, but I didn't read the content of it so much.
Oh,
About David Morris. Is it this David Morris, this article, or it's about a different one?
no, it's something different.
Okay, all right. So, so Morris has, okay, first of all, Curmudgeon Corner is a column that I edit, and I encourage you all to submit, because it's supposed to be like letters to the editor, and it's for people who have something to say about the emerging technologies, social impact technologies, especially AI. That can be said in very few words, like 1,000 or 2,000 words. Not an academic article, really quick, has to be, of course, informed, and also makes the point that maybe it's different than what the standard opinion is. Okay, so and that would be, it's a form for that kind of thing. So, and it's really quick. It comes out and it's posted, it's a quick process, basically. So that'd be fun to do. And it doesn't have to be about AI, it can be anything involving technologies. Probably more focused on algorithmic technologies. So that would be great. Okay, so this little paper is the letter to the editor that David wrote about magical thinking. Right. Let me look at this. Okay. So can somebody give us a little synopsis of, there are two parts to this, right? 2 points, but the one point it starts with this notion of magical thinking. Can somebody give us a kind of a informal characterization of what he means by that? I'm looking for examples here.
What I kind of took away from that was that something can look like a thought, be presented as a thought without actually being a thought. I mean, I think the examples used really, at least for me, helped to make sense of that. Like, a tool that can create a smell, that doesn't mean that it has a sense of smell,
Right.
because it can create one.
Yeah, that was one example. And another example being weather model. Weather model, goes back to the simulation point that I was talking about at the beginning of the class. And that's a really deep point. Here at ASU, there's a very important center called the Beyond Center. Has anybody heard of it? It's run by Paul Davies and Sarah Walker, super sharp. And it's about the origins of life. They're talking about origins of life, or searching for life in the universe. Sarah gave this really interesting talk last fall, Sarah Walker, talking about how it's just as likely to find alien life on this planet all around us as it is to find it in outer space. And she was making the argument that computational forms might be a form of xenolife that we can't really recognize because we're looking for things like us, and so it's actually, I think it's very provocative. I think it's wrong in the way that she does it. I think it's right, the general point, but the model she points out is worth talking about. It's based on a formal model of structures called assembly theory, based on basically like Tinkertoy structures. And there's a formal mathematical theory of how you get more and more complicated Tinkertoy structures together. I'm not doing justice to the theory. It's a very sophisticated theory of how to measure complexity. Okay. And this comes all the way back to last week when I think Cameron pointed out some comment about in complexity theory, we work with graphs, and the basic structure for complexity theory is thinking about nodes and arcs and graphs and things like that. So, but David's point is that, well, having a drawing of something is not the same thing as thinking, you know. Like, so maybe some other examples. Keep off the grass. That was another example from the paper. Keep off the grass. The words just painted on the sign, on a stick, on the grass. Let's say, well, if I just see these words, then usually I obey, you know, but why? You know, like I'm ascribing to these words some sort of power, like it's somebody there standing yelling at me, hey, keep off the grass, but there's nobody there. It's just a bunch of paint on a piece of wood. So we ascribe to it this kind of agency that it doesn't actually have. It's not a living being telling me yelling at me to get off the grass. And it calls that magical literalism, which is to conflate the recorded results of an expressive process of thinking with the thinking process itself. What do you think? It's tricky. It's tricky. Yeah.
I think that thought relates to me the same way I talk a lot about maps and why people believe them. And if you put something on a map, then it takes on a weight, and it's really important ethically to make sure that what you're presenting is represented well on a map, because people believe it.
The map question is super complex, because if I put down a string of words like keep off the grass, or an LLM that ChatGPT generates a whole string of code that could have been typed by me or some human programmer, that's one thing. But it's interesting because the syntax of a map is a lot more complicated. It's hyperdimensional, really. So normally human bodies, we don't normally, without all these tools, we can't just spit out diagrams, maps. So super interesting, I think. And yet you're saying, Tanya's saying that they have this kind of agency. They could have this agency to them. So that's not literalism anymore. It's magical thinking, but it's not literal, you know, right? As if it were spoken or done with a hand. It's not literal in that sense of literal. Yeah, interesting. So yeah, so this kind of ascription of power agency is a lot more than just the kind of keep off the grass example that David points out. Another more fundamental thing is the weather system. He talks about instead of a large language model, a large weather model, LWM. He's being kind of funny. So it's a model of a storm. That doesn't mean it's stormy, right? A model of a storm is not stormy. And Wittgenstein is going to say things like this too. So there's one phrase in Wittgenstein where he says, never confuse a statement about hesitancy with a hesitant statement. Okay. So it's very nice example. And philosophy, he criticizes himself, he criticizes philosophers for somehow conflating these two things. So, but then we see this already happening with generative AI. Okay. So.
I have a lot of thoughts about this reading. I agree with the magical thinking concept, but I don't necessarily think that it's a danger, as Morris claims. I think that it's, you know, the use of generative AI by people is a mindset of learning and
Of learning.
Oh, learning.
Yeah.
A mindset of learning, guys, is a mindset of learning that I think a niche group of people will use as exclusive knowledge, but I don't believe in like the concept of technological singularity in that case at all.
Only certain people think that, but not most
people. I mean, other areas of research and discovery and stuff will, potentially use generative AI as an asset in research, but not, the exclusive knowledge. And I kind of got that vibe from this paper. And it really reminded me of, I put this in the Padlet, this specific reading, but it's written by something Stokes. I don't remember his first name. I think it might be Charles. And it's his understanding and his description of, well, actually he created it, Pasteur's quadrant. Are you familiar? Is anyone familiar with that? Okay, well, I have it here. So essentially it talks about, yeah, let me join the Zoom real quick.
Yeah, go to Zoom and you can share it because you don't see it. Yes.
Okay. More cookies.
Yeah.
All right, let me share. Okay.
Rude.
We'll eat the representation of the cookies on our screen.
Okay, can you, yeah, okay, everyone can see this. So it's really cool. So I don't have a full deep understanding of it yet because I just learned this in one of my other classes, but I really think that it applies here. So it's obviously, a table that talks about discovery as like, do people discover things because they want to use them or do they want to understand them? And you guys can probably use common sense for the three that are filled in, but for the one that's blank, there's a theory of research as like bird watching. Like it's like just civilian based science and it's not rooted in intellectual discovery or anything like that. And that's kind of where I would personally place artificial intelligence in this cube here, specifically generative AI.
Where would it fit? Which
The blank one.
I was thinking about that.
Yeah, because the one with Bohr, it's just research with just because you're interested in learning, and then the Pasteur one is you want to he discovered vaccines and the concept of vaccination, so that's like you need to find something to fix this problem, so yes, it's only for use, well it's not exclusively for use. And then Edison, he just discovered things just practical stuff. He didn't really care about understanding. He just wanted to figure out things to use, like, oh, there's a problem we can't see without lighting a fire, therefore light.
Very nice.
Isn't it cool?
Very nice point. Very nice point. Yeah, very nice point.
So anyways, that just reminded me of that.
It's in the Padlet.
This article's in the Padlet.
Super interesting.
Yeah, anyways.
No, I think so. I think it's interesting.
Is that the one you opposing arguments to Morris?
Yeah.
Or
I guess it's kind of supplemental.
supplemental.
Yeah.
Because in a sense, it goes more to the second part of this little letter, which is about what we think we do and what we ought to do. Think about what it takes to be an intelligent human. What should we be doing?
Like the term civilian science.
Yes. Citizen science, citizen science. This is citizen science.
Citizen science.
Okay. What do people mean by citizen science?
I think it's just basic observations that non-scientists make in everyday life that impact the way that they see the world. It seems so incomplex.
And this is youth-inspired stuff. ASU is big on youth-inspired research, right?
Yes.
There's also something else. Stacy Kuznetsov is here at AME. She's a faculty here, and she's been doing her whole career what they call citizen science, and that has to do with. Have you taken any courses here? Maybe. Anyway, she has a whole lab called SAND lab, SAND. And they help communities build custom sensors to understand their lived situation. So like, pollutants or stuff. And solar powered ovens or whatever. And the thing is that she's very interested in what they call citizen science, meaning having citizens do science.
Yeah.
Right? And, build instruments, build their observations, build their measurements, do their own statistical analyses, things like that. To do what scientists do, basically.
Yeah.
But not in the institutions. Yeah. So
In
that's
meteorology, there's a lot of citizen science, like reporting on weather. What are you observing? Report that back. That's like.
yeah, absolutely. That's interesting, isn't it? Yeah.
Yeah.
And astronomy too. Well, used to be. Now it still is. Yeah.
Yeah.
Astronomy too.
I think I put an article in the Padlet or a little, maybe 2 weeks ago about like civilian science's role in meteorology too. It was really cool. Maybe I did.
Speaking of which, I really enjoyed the videos you have. Well, you have a lot of videos.
Thanks.
And that little one of the cup, the plastic cup with the hole in it. I think it's really great. So, okay, human use of humans. The second part of his article, I think, is related to what Morgan's saying here, is probably even more important, is what we take to be intelligent. Meaning, what do we do in order to be counted as human, and what do we do in order to be counted as intelligent? That kind of thing. There's this mathematician named Giuseppe Longo who talks about machines and automation, and he's a computer scientist and magician. So, but he made this interesting comment about how people get worried about being displaced by robots and AI. I said, well, look at the kind of jobs that people are supposed to be trained for. If the kind of work that we ask people to do is mechanical, then it makes it easy to be replaced by machines. So, so it's not a surprise. The problem isn't so much this thing about machines, more about the kind of work that people are asked to do. So, or the way that people are asked to think in terms of mechanisms. That's it, basically. I don't think there's much more here. Yeah.
I put a sorry. Oh, I put a paper in the chat. It's Melanie Mitchell. It's called AI is Harder Than We Think, and it's 4 fallacies about artificial intelligence, machine learning. And I think it applies to what you were just saying. And there was one part I thought fallacy 4 was especially good. The fallacy that thinking occurs in the brain. And then it's a disembodied process. I just thought that might be interesting to consider.
Great, thank you so much. That's really important. What you just said there, that thinking happens just in this conceit that thinking happens in the brain, is it really needs a lot of repetition, because it's something that we have a problem with, for example, neuroscience, or rather appeal to neuroscience, right? I mean, I guess in the mid-20th century, physics was the king of science, and that, so basically other science would be measured with respect to how much like physics they were. And then we have genetics. We have the era of, well, still is, dominant, this idea of what's called the fundamental dogma of molecular biology, which is the idea that everything we need to know about biology, we can basically read out from DNA, or how the genetic mechanisms work. And that's another dogma. And now we have this idea of neuroscience. If you want to think about thinking, well, let's go to neuroscience. So, so this is actually a very important article to look at things like that. And other articles would be looking at the fundamental methodological problems with neuroscience, like this idea that well, several. One is that mental faculties, or let's say ideation faculties, can all be read out from the neurophysiology of the brain, this kind of gray matter organ here. And another is thinking that you can infer the global function of the brain by doing point measurements, just getting data measured at specific points, or by doing very local studies of what happens when the brain has a lesion at one location, and then some faculties get damaged, as if that proves that that faculty is only related to what happens in that portion of the brain, which doesn't have to be the case. Okay, non-locality. So things like that. Okay. Okay, let's keep going. Now we go to games. For that, I want to take a look at the slides.
That one was cool.
The C card, yeah?
We're
Yeah.
looking at ourselves, looking at ourselves.
Yes, it's very circular. Proceduralism. Okay, so what does this C card mean by proceduralism? First of all, just starting out. We can take a look. I mean, first of all, I think, let's see, we have several, the majority here have written code, right? You've all written some sort of code, some sort of, in some language somewhere, right? Like whatever. Python.
Long ago.
Okay, so, yeah, so, so know something like, the notion of the basics of procedural programming language. This idea that there are these variables and constants and logical operators, right? Okay. So when he talks about procedure, he's thinking behind this kind of procedural, it's called procedural programming languages. But just out of curiosity, has anybody ever heard of or worked with other kinds of programming languages that are not procedural programming? Procedural meaning like Java, Pascal, C++, C#, whatever, Python. These are all procedural programming languages. But there are other kinds too. Anybody here? Interesting. That's a sociological point. Yeah, interesting. Or first of all, HTML is not a programming language, really. It's just a description of structure, right? So programming language would have to do something, right? Cause a change in the state of the computer. Okay. There are other kind of flavors, whole families of programming languages. I should probably mention, and to give you some idea of the kind of the narrowing of the zoo of paradigms that we have in computer science now versus when computer science was being formed. Because there are also image processing languages. Like example would be like Touch Designer or Max MSP Jitter. Some of you, has anybody here worked with something like that? Yes, okay, like an image. Like you take two images and add images together, or take two images, you multiply two images together. This idea of we can operate with images rather than operating with an abstraction like this variable is an integer variable, this variable is a string, okay? Or sound. People working in the domain of sound, this idea that I bring in one voice and now I want to introduce another voice into the stream of audio that's coming out through the speakers. Or this idea of spatial audio, right? This idea that we're in a room and there's all this sound coming off the walls. So this idea that, oh, I want to now hear this sound source flying around my head, around and around, and just be able to do that, thinking in terms of streams of time. There are languages for doing that. So, right. So procedural programming language is a very, very particular kind of language inside computers. So that's part of what's in the background for this paper, right? So now let's go down. So what are some characterizations of procedural? Yeah. And what's this beef? What's the beef here? What's the problem? Look at the slides. Oh, come on. Here, too many. No. Okay. It covers a lot of ground, so. There must be more paper somewhere.
Some of the restroom.
Do you think it could describe a whole bunch?
Yeah.
Thanks. Meanwhile, I want it.
So I had never heard of proceduralism before. And when it started by saying procedural rhetoric, I was like lost. So I Googled it and read several Google definitions. I'm still not entirely sure I understand it, but the one that made the most sense to me said that another way of defining procedural rhetoric is, oh shoot, I forget if it was stimulation or simulation. But stimulation? Simulation rhetoric. A concept that explains how people learn through the authorship of rules and processes.
Say again.
A concept that explains how people learn through the authorship of rules and processes, which obviously focuses a lot on like the author being at the center of it, or the designer, and that's what he ultimately says in the flaw. But that as a starting point makes more sense to me now after reading it than it did actually when I just first read that. I was like, okay, what does that mean?
Let's think about if you want to tell a robot how to do something, you know, like let's start with something else. Recipe, favorite example. Want to tell somebody else how to cook a dish. You have a list of ingredients, and then you have a bunch of steps, right? Steps. That's one key thing. Step by step by step. Right. First, mince the ginger or whatever. You know, chop up the scallions. You know, take the eggs, break them up, and keep the yolk, but not the other way around. Keep the white, throw the yolk, right, and then beat it up. But stuff like that, right? So you have this prep, etc., etc. So you have these steps, and the order of the steps is important. Well, sometimes, right? Like it's very funny, but you know, say you learn things like, you know, my mom taught me fry up the onions before you add the vegetables, you know, or chop up the vegetables, add the stuff that takes longer to cook first before you add the later stuff. And these kinds of rules of thumb. Those are rules of thumb, which are different. I mean, those are rules of thumb. But then the actual procedure is, you know, specific, step by step by step. Okay. But already, if you now think about a robot, you want to tell a robot what to do, that's probably not enough. Right? You can't just from scratch if you try to, you know, instruct a computer or a robot. These are very high level instructions, like chop up the ginger, you know, mince the ginger. But exactly how to do that, you know, with a little servo motor and a little knife and things like that. Chop, chop, chop. When to stop chopping? How does it know when to stop? You might say 50 times, but maybe 50 times isn't enough. So then we begin to get into the actual nitty-gritty of actual programming. And then it becomes really, has to be very definite. And you have to have, let's say, for example, a termination condition for a loop. And in this case, you can't just say for n gets 1 to 100, you can't say that. You have to say, you have to put a termination condition. So that becomes part of the instructions you have to give to the machine. So think about this. So in order to make it something that can actually be efficacious, we're talking about something which is now fairly indeterminate, right? When do you stop chopping? If what you have to work with are logical operations, like you can assign a variable, you can count things, you can index things. What about and some logic, if then, and some case. These are atomic. In this paper, they mentioned unit operations. What do you think could be meant by unit operations? I didn't come across that before this paper. I thought, oh, it's interesting. A unit operation. You know, those of you who deal with programming, what do you think this could be meant? Could be meant by that? Or without the paper, just lifting up from the paper, just thinking, you know, as a programmer, or what could be a unit, or in terms of software, what could be a unit operation? I think he's kind of inventing it. Let's go back to programming languages, you know?
What the program can do with the given data, if we're still talking AI.
And what makes it a unit, an operational unit?
Yeah.
I'm not sure. What do you think?
The unit I would say is like a program that we're using. That's being used. So if we're still talking about AI, which
Yeah.
I did invest a little time in AI, like when it was starting to get popular. So I'm not ready my thoughts exactly to what I'm trying to make a point here.
Yeah. Well, can you talk about something?
So generally from my experience with topic behind with the topic behind connecting with that stuff, it's just with basically just getting data from the internet, like which is partially like stealing from artists and all that stuff. And it's a fun topic, and I can talk about for hours, but I'll speed through it. Basically, just if we're talking about like coding, like coding language and stuff, I would say it's basically just like I said the first time, just the programs or AI and the information you give it and how it functions with that information.
Okay. So that's a high level view where the whole program is given. The whole chunk of code is given.
Yeah.
I'm trying to think about, operation. What's the operation thing in that sense? That's good.
What it does.
Just running the whole program.
Yeah.
Okay. So we can start fine grain. So we can start with a fine grain thing. If we have a programming language, there's some primitives of the language, some basic operators like if, then, right, for, next, equal. Okay, so this assignment, for example. Sorry. Okay. So notion of assignment, right? The notion of variable. Notion of assignment is very fundamental, right? So assignment is an operation, X gets 5 is an assignment. So X gets 5 is an operation, assign this. Another thing, there are arithmetic operators, right? Plus, minus, times, divide. Okay, these are also operations. So you add two variables together, that's an operation. So I think these are very concrete. Also there are things like if-then loops. If-then statements, logical statements, and then there are loops. So there are more. There are many more structures. Okay, but these are basic structures, right? Basic structures. Many languages have them. Okay. I have notion of variables have data structures. They have structure, right? So the fundamentals, there are strings, or there are integers or floats, right? Basic types. And then you can build compound types out of that. Okay, so I'm talking about something very basic, stuff like that. So operations would be operations that you can do with data. Data for programmers are just basically built out of these kinds of basic types, strings and numbers, basically. Oh, logical, true, false. Everything else is just compound, basically. If we're talking about classical procedural languages, whereas the examples I chose earlier, image and sound are basic types. That makes it really interesting. So just say these are kind of the hallmarks, the fundamental hallmarks of a procedural programming language. I'm deliberately doing something very, very elementary, because I think behind this theory is some very elementary notions, set of notions taken from computer engineering and then theorized into things like this, to media theory. Okay. So an operation would be something like this, a logical operation or a numerical operation or assignment or comparison, right? Basic things. Unit operation, then think about this. Unit makes me think of one, right? One thing at a time. So one step at a time, applied to one object at a time. So what would not be a unit? And I was thinking about that today, preparing for today. I'm thinking, Remember, in general, it's always useful if we have a notion to have a unit notion that's not universal. Like everything's a unit operation, that doesn't help. So, okay, so he's a unit of operation, but what do we think would be not a unit operation? What do you think? Doesn't have to be computer programming.
Well, I guess to me, it's a unit if something can be, if it can be operated on all at once. So it could still be a group, not a singular, but you can apply one operation all at once.
Yeah, all at once. That's unit. That makes it a unit. In formal language theory, it can be also called atomic operation. Doesn't get broken down into further things. Yeah, okay. I was going to show you. Yes, okay, maybe I can. I have it running. Maybe it's still working. For fun. Oh, wait, is it still sharing? Can you guys see this? I don't see them. Can they see me? Zoom.
Yes.
Yeah.
Oh, good, good. Okay, I'll make it bigger. Is the camera working? Ah, yeah, camera's working. This is Max. I'm running Max MSP. It's a patch that basically works with a little bit of camera-based motion tracking. So I'm going to train it off. Ooh, okay, turn on the sound. Can you wait? Can you hear anything, you guys, in the Zoom land?
Like yeah, like a wow wow.
Okay, all right, good. Sorry, I don't have.
I don't know if that's a human or the.
Okay, I'm gonna choose a sound. Make it. I'm not gonna tell you what it is yet.
Right on the stairs. What's he building in there?
If I know this.
Tell you one thing, he's not building. But he asked for the children. What's he building in there? What's that sound from underneath?
So I would say this is not exactly a unit operation. This is a continuous operation. I'm going to try to play the original sound for you. This is the original. I hope I have it.
What's he building in there? What the hell is he building in there? He has subscriptions to those magazines. He never waves when he goes by. He's hiding something from the rest of us.
It's a song by Tom Waits, okay? And now I'm going to modulate it with my
Underneath the door. He's pounding nails into a hardwood floor.
It's by degree of motion. Oh, I'll give it to you. It's just some Maxwell there. It's a Maximus Pico. So it's one of my favorite demos, basically. So this is working based on motion. It can also be based on presence.
Hardwood floor. I swear to God, I heard someone moaning low.
What presence is?
I keep seeing the blue light of a TV show.
These 5 hands. Presence is basically how much of the field of view is obstructed. When I do training, what happens is basically just basically this background subtraction. So that means if you were to look at the trained image, it would just be black, but you turn it on and then off, it would be black because wherever I am right now, just taken as a background constant image, I subtract that constant image from all subsequent frames of video. So if I'm not moving, it would be black. This is an example of image-based processing logic rather than primitive work on fundamental types, data types. And then if I go like this with my hand,
He has no friends, but he gets a lot of mail.
I'll go back away.
I bet he spent a little time in jail. He was up on the roof last night signaling with a flashlight. What's that tune he's always whistling? What's he building in there?
All right, so this gives you a little bit of a flavor of non-unit processing, okay, where it's tracking gesture continuously. So it's not unit in multiple senses. One is these are working with data structures that are like whole regions rather than one point at a time, like one pixel at a time. It's also working over time, durationally. So the degree of movement over time. All right, I just want to give you a really different way of thinking of and looking at things. This is just tip of the iceberg. Okay, amplified. Okay. This paper here is about classically programmed things like procedural programmed games, which are based on top of languages like whatever, Java or C++ or what have you. Okay. So the theory, though, is his point is that procedurality is somehow elevating this kind of basic mechanical way of instructing a computer to how people should think. People should think that is that these people who play the games, that they're learning something from the games by thinking procedurally, like or mechanically. Like my daughter plays, she's 10 years old, she plays Among Us. Has anybody played that? It's very popular, right? Among Us. So it's a murder mystery thing, right? So you get set, it's really fun, but then I watch her play and she goes through the same moves all the time, over and over again, right? Dead body discovered, have a meeting, vote somebody out, goes into space, oops, wrong one, that was not a imposter. So it's really funny, right? But it's the same moves over and over again, the same procedure over and over again. Of course, there's a lot of sideband chatter, and that's kind of the fun of it, right? But still, after a while, I said, it's the same steps over and over again. And this is part of the point, that the game state is pretty sparse, and there's a small finite set of operations that the player can do, small finite number, and also there's a small number of options you can do at any point at any state. Okay. So, and most importantly, those states and operations are defined in advance before you even start the game. So these are kind of fundamental qualities of a procedural way of thinking. That is, you define the ontology ahead of time. What are the entities under discussion or operation? You define ahead of time the operations you can apply to the objects. Ahead of time you decided. And then you have a finite number of states that the whole game or program can be in.
Would meta or the possibility of change, like rules or procedures at a meta level that allow for the change of the base layer of the game still be considered procedural? Like if there were aspects of the game that,
Sorry, what do you mean by meta level?
Like if there were meta rules that allowed for rules to change.
Yes, there can be, right? You can always do that.
But would that would still be procedural?
Because it was specified in advance.
Yeah.
Well, I shouldn't lay it on procedurality, sorry. This thing about being specified in advance is even more fundamental than procedural. It's just that any program of any flavor, if you write it down the code ahead of time, ahead of when it's written, ahead of when it's executed, there's antecedent existence. And this is going to come up to be very important. In fact, from our seminar from last semester, we read that biology doesn't work like that. Biological organisms and evolution doesn't work like that.
Yeah, exactly.
So that's the Kaufman thing. But I want to zero in on this because here this paper is criticizing both the way that computers are programmed using procedural logic and also how people are expected to discern the meaning of a game by going through this kind of rule-based procedural mechanical activity. Okay. To be fair, I think there are lots of games that don't work like that. Okay, it's just a very particular class of games.
Right. I was thinking like Minecraft or.
Exactly.
Yeah.
Yeah. In fact, that was going to be my example of Minecraft, for example. Yeah. A lot of world building. But even there, you can say that, well, just that's distinct. Okay. So what's the problem with this kind of mechanical thinking? What's the point here? Soul and soul. What for Seacard and for us? There are two kinds of problems. One is the mechanicalness itself, and there's another issue, which is the whole notion of meaning. Because here talking about games are supposed to be socially good games, like teaching morality or something, or having a point to it.
I pulled out a line that says, without the player, there are no ethics or politics, no values, and no messages. So basically it's that you have to take the player into consideration and give them more, I guess, agency. I'm not sure if that's what I'm trying to argue, but that's kind of what I took away from it.
Yeah. Yeah.
And that it's more personal.
And he talks about this thing about the instrumental play, what he calls instrumental play, that there's a point to it. I mean, okay, it can be very much intrinsic to the game, like you have to get through some geometry, or you have to get some prize, or you have to, bring your character into a certain state or whatever. Okay, but those are specified for you. So instrumental would be for purpose. Okay. But then, like Minecraft or some other kinds of situational games that don't have a purpose, they don't have to have a purpose. So I think that's okay. I think that's one issue. I think another key point that they make is thing about rules, following rules. I mean, think about it. I mean, in a software program, everything's done by rules. Everything's done by rules here. These are all rules for the machine to play. The machine cannot do other than what this instruction tells it to do. Okay. And in this paper is actually pretty delicate, trying to think about, well, the kind of mechanicalness of the way the games are underneath the program and or what people are supposed to get out of it. Aside from the moral part, what about just play? The enjoyment of it. And enjoyment of it cannot be explained in terms of the grind, just going through the motions. Enjoyment of it. So that's what I wanted to bring up, is this distinction between games and play.
Yeah, there are some games. Did we talk about this last semester? There's like a game where you just click on a cookie clicker or something.
And what does it do? No.
It doesn't do anything. It doesn't do anything. You just click on the cookies. I don't understand it. I don't like games like this, but I guess it was wildly, like, a lot of people play this and they.
You can beef up your clicking abilities by
that's it?
well, it's like if you click it 100 times, then you have 100 clicks, 100 cookies, and then you can like feed a grandmother, and then a grandmother will produce 5 cookies per second, and then it's just like recursively more and more sophisticated cookie machines.
So the grandmother is a fictitious grandmother?
Yeah. It's like you see like a icon of a grandmother like cooking on the side. So it's a little bit more sophisticated than just sitting there clicking, but yes, it's very simple. In that game's defense.
Yeah. I mean, think about it. I think I'm quoting here the words. I think that's what you were saying here. You guys are saying player as the living, what's missing? Okay. from this kind of proceduralist way of interpreting games or designing games. Is a player, thinking of the player as a living, breathing, culturally embodied, ethically and politically engaged being, that plays not just for some purpose, but also just for the sake of play. Okay, but the key thing is this: we're talking about living beings engaging in this activity in some social context that allows them or enables them, or in which this kind of play makes sense. That's it. So, and that again goes to Wittgenstein when we talk about not just what games mean, but how words or any piece of language, how it means something. Okay. Let me show some more pictures of examples I have for play. I want to share with you. It can be fun. Oh, well, we'll skip. Actually, I'd like to comment here. Do you guys see this frame, slide on Adorno and Horkheimer, Tanya and Cameron? Okay, good.
Yeah.
So I want to make a point about this with large language models again. Okay. Have you guys all heard, I think everybody's heard about these different ways to poison LLMs and the way that these LLMs are trained? There's some 3 really important, interesting papers that came out over the last year. The first one is ways to, how ChatGPT, it has guardrails, so it's manually tuned by the engineers so that you can't get it to say certain things, right? You ask it to say certain kinds of things, it will refuse. These are post facto, these are added in as extra rules that govern the range of expression of ChatGPT and other LLMs, okay? So there's a lot of hand tuning, a lot of cheating, basically. However, these people found a way so that you can embed a string that looks like gibberish, tack it onto your prompt, and can basically break a lot of these rules. You can start spewing out all sorts of horrible stuff. And these people wrote a paper about it. And what's really interesting is that the gibberish is calculated mathematically. So it's not random at all. It looks like gibberish to the human eye, but the string is constructed so that it's in order to break those guardrails. It's super amazing. Okay, I think those people are currently known. The second paper is about about text. Is how you can so-called poison the weighted strain by giving it a small number of images that are constructed in order to break the categories into which the training sets are formed. So you can make, for example, things like sailboats are classified with mountains or classified with new people, whatever. So that's a way of breaking the kind of semantic categories, supposedly semantic categories that these LLMs or these large language models are supposed to form. And the third one is, I think that's the one, well, one of these two, maybe the third one is really amazing, where maybe I'm getting this mixed up. The third one is what I just said. The second one is the one where you can actually embed pixels just in the images that are being scraped for training. You can actually embed certain pixels and tweak the pixel values, just so that to the human eye, the image looks just as before. But in these little pixels, you can poke them, spin set the values, it breaks the categorizations that the models are making. So it's just insane. Now my question is, how come this kind of thing can even work? Just in a very high level.
What was the question?
How can this work? Not the details of mechanically how it works. This is very intricate research, okay? But just in principle, why do you think this kind of thing can work?
The poisoning, why? Yeah. How does the poisoning? Why does it work? Because
why? But why? Why?
It works because the AI generators don't actually understand them. They don't know what they're looking at. They don't know.
They don't know that new people sailboats are not the same, right? They don't know that this picture of Van Gogh and that picture of Van Gogh, that this is legit and that one's been poisoned. Somebody has to tell them that. And they don't know that, my text prompt, which has a whole bunch of gibberish to it, I say, write me a story that makes me sound like Hitler, Mein Kampf, but, in my voice, in the way I would write, and then add in this like 100-character string, it would just do it, right? Because there's nobody sitting at the console and they say, oh, she was trying to do something bad, so don't let them do it. Somebody has to make that assessment. And that's the key. These algorithms all work on they all work formally. They are formal procedures, formal. Or in particular, for programming, these work syntactically on syntax. What's syntax? Anybody want to give me a kind of ballpark syntax for language? What does it mean? In terms of linguistics.
Just like the way that words and phrases are arranged.
Yeah, the arrangement. It's the way they're arranged, not what they mean. Arrangement. Like in programming languages, syntax, right? It'd be like, I don't know, syntax is the variable being assigned to is on the left-hand side of the assignment operator. So syntax, you don't say 5 gets X, you say X gets 5, the order, the way things are arranged. But, so it's a formal relationship. Okay, it's abstract in that sense. It's not whether it's made of wood or not because Xin Wei woke up today, I feel like this or feel like that. No, syntax doesn't care about that. Okay, so formal in that sense, formal and syntactic, so that they're independent of materialities, they're independent of psychology, independent of emotion, independent of history. Okay, those are all ignored. They're irrelevant. And precisely that, all of that, genealogy, history, emotion, politics, value, ethics, that's what gives meaning. Right? That's why these formal methods of classification can be broken this way, to make them to say things that are horrible to me, to us, or whatever, or stupid or confusing, because that's all involves questions of meaning. Okay. It's a profound point here. Okay, let's have some fun. So why don't we show a few examples of work that we've done in synthesis in a topological media lab. And forgive me if you've seen some of this, but I don't think you guys have seen it in that semester, right? This work. Yeah. This is inspired partly by what was this experiment? Well, this is basically we were doing some work back in the topological media lab on how people invent language from kind of without using words. It's how people invent a language using gestures, and we were shining responsive video onto the table, and we had some responsive sound going in the large space. So they were basically computed out of gestures and whatever the cameras could be seeing, with no a priori notion about what is a person, what is a body, just based on optical flow, etc. And we had dancers around the table, and we had visitors at this table, maybe like 3 and 3 or 4 and 4. And the people who were visiting, we didn't tell them that who were what do you call them? Who were the rehearsed people and who were just visiting. And we said to them, get to know each other, let's have tea, and just introduce yourself to each other, but without words, okay? And we had on the table some props, teacups, pots of tea, cookies, whatever. and it has something to eat and work with. Then, but don't use words. Just go ahead and introduce yourselves without using words. So that was a constraint, and they were having fun. And then after about 10 minutes or so, they started to mime, right? How to invent things. So people wanted to see how people invent meaningful gesture with each other. And then we wanted to see also what difference does it make when the light itself is responsive to the gesture. So this light is dead light. This light that we have overhead, it just holds dumb illumination. But if we had a shadow like this light, you guys can't see, but I have my hand about 3 feet off the table and shines kind of a big fuzzy shadow on this table here. So this shadow of my hand on the table doesn't add much in the sense information to this hand up above the physical hand. But if the shadow of my hand on the table were doing something interesting, like started to walk away or float and wriggle his fingers, even when my real finger is not wriggling in response to other activity, that's interesting. Okay, it adds an extra layer of some interpretable sign. So we were also doing this research on what if we had an environment where the media itself is actually has a little bit of its own behavior, is clearly coupled to the physical motion of the body, so it's an extra layer of articulation. Okay, could that help people invent language? Okay, so we did that, and then we came in, we took away the props, we took away the teacups and the pots, and say continue. So then we had fewer things to work with, fewer objects to work with to articulate communication, and there had to be even more, expressive with their bodies, because these people who came were not all dancers, so they weren't going to be all so comfortable. Finally, we also had the dancers themselves who knew how the systems work, were rehearsed. We told them to be more and more provocative. So they started to put their, hands over the table, sit on the table, whatever, take the chairs. So it became more and more provocative to see if these people would be encouraged to be more inventive. So that's an example of the research we were doing using computational media, completely different than this kind of procedurally written story is going to teach people how to be more logical. Okay. All right. We learned some things. Oh, that's the fan right here. So it has to do with thinking about language, not in terms of words, but in terms of language in the activity as a way to coordinate attention and to coordinate intention. Meaning, what do people pay attention to, and what do people intend to do or to think? So this is a much more supple characterization of language than just the usual linguistic things in terms of grammar, syntax, phonology, blah, blah, blah. Okay? So that's playful. All right. What time is it? Do I have 10 minutes? Yeah, 10 minutes. Okay. Play. We can discuss what they mean by play, et cetera. I'm not so satisfied with all the different characterizations they have of play in this paper, but I think it's something really worth talking about and thinking about. But to prepare for Wittgenstein next week, I'm going to ask you to look at those sections from Wittgenstein. Again, the basic question is there a way to think about how language means anything? And maybe the key thing throughout the semester is to try to move away from thinking about nouns to thinking in terms of verbs. So instead of thinking about categories and objects and what characteristics they have, like what is a cup, to instead thinking about words relationally. How do words or phrases or sentences make meaning in the field? And also how they have meaning in use, in practice, okay? So, and here's one that has the last two pictures. See, the first way, thinking mechanically, and thinking about social meaning, etc., activity, would be what I call gear. Thinking of the world as a bunch of gears. So this is just an analogy. So thinking about how maybe if you have to think that everything that's done has to have a deterministic relationship to everything else, because that's how computer programs are written. They have a deterministic relationship. Okay. Then what we would get is a social technical set of infrastructures that are like gears that fit together. And you would think that if they fit perfectly, that's what you want. But if you think about it, if everything in the world, in terms of infrastructures and technologies, are fit together like gears, then the question is, how much energy would it take to make a change in one gear? Well, look at this picture. If you want to rotate one gear and the whole planet is geared up, that's a lot of power, right? In fact, the power requirement to make a change in any part of the social technical world is going to increase without limit as you expand, have more and more systems interlocking together. Okay. So these systems are really, really maybe strong, but immovable. And here's an example. I'm thirsty.
Whoops. Oh, you're gonna pour water all over yourself. She's really strong. Oh my God. Not done. Want more? Want more? Where you go? Okay. Oh my God. Go. Go. Whoa.
So how is this playful? No words, no plan, no rules. And she knew that she was funny.
That's it?
She knew
Is that
she was
it?
funny. She knew she was funny. She knew.
One last drink of it.
Okay, so I have to forgive me. I have to be a little bit partial to this one. She'll be very embarrassed if I told you that I showed this video. She's a lot bigger now. Okay, guys, that's it for today. Next week, I'll see you in Zoom. But really think about this kind of example when we talk about things like play and procedurality. All right. I'll start with this. Okay, guys.
Thank you so much.
Bye-bye. See you next week in Zoom.
Thank you. Bye.
See you. Bye.